All right, in this video, we're going to go over how to use Terraform to provision a couple different kinds of databases within Cloud SQL, as well as some other resources you can do. So there's some pretty good documentation for Google, as it is one of the main providers of Terraform. You can see there's all the kind of different types of resources you can create. The one we're interested in is Cloud SQL. So they kind of give some boilerplate kind of code. So we're going to test that out and see how that runs. So it's pretty cool. Within Google Cloud, you have what they call a cloud shell. So that just pops up your own instance that runs. And funny enough, it already has Terraform installed. So they also have this as well as an editor where you can upload different files and be able to run it straight from Google Cloud. And this kind of passes the need for having a service account. If you're running it within a VM, you're going to need a service account or some way of authenticating, being able to create resources. Whereas we're in the Cloud Shell, we are kind of the main super user, especially in our own projects. So you can be able to have the permissions to use Terraform. So you can see we're in this folder, got the main.tf. So here's what it is. Let's try it out. So you do your Terraform init. So that's what you do the very first time you're running it within a directory that installs the providers. So in this one, it's Google. You can see. So now we can go run our Terraform plan. It's going to give us a dry run against the current state. So our current state, or how Terraform sees the world, it doesn't see any resources that we've created. So it's going to say everything that we're trying to add, everything in the file is going to be added to, meaning we're going to add a database and an instance. Let's go ahead and run that. We're happy with it. So yes, it's the same. Here's where we give it the permissions. Let's see, it's creating. So we can actually go over to our SQL I have it pinned. For other people, it's going to be down in databases section and in SQL. As you can see already, whatever loads, it's starting based off of the name that we gave. So we go back to our Terraform just to verify. The name of the database instance is Terraform. We're running in US Central 1 location. Once it pops up, when we look into it, we can see that it's going to be this tier, which is the lowest tier. While it's running, we can look at pricing just to show you how fast things might run out if you leave it going. And I think it's a lot of variables that play into it. But here's kind of what we're looking at for a instance. So we're in the DB F1 micro. So hourly, we're spending $0.015, cent and less than that. So that's hourly. Then $7.67 a month. And then we add SQL Server on top of that. Per vCPU, which it's shared, so I don't know how it sees that one. We're doing that per month, that per hour. You can see a few different things if you do high availability, things like that. So just give you a good idea of how fast it would run out. If you just left it running, you're going to want to make sure that you cancel these instances after you can verify it's ran as soon as you get your assignments done with it. Go back and we'll look at what's going on in the terminal. Usually this takes, I've seen it take from anywhere 10 to 15 minutes because it's going in and it's clicking all of the different options going through. Terraform is defining it. So it's saying, hey, here's kind of the state of the world as you want it. And then you declare it. So it's called declarative state rather than imperative. And Terraform has the imperative mapping to the provider to take the steps to create this in a consistent way. So we'll show you how we can use the same or similar code to create another database and different resources. All right, so you can see it took about 9 minutes to complete. But if we go into our Cloud SQL, we can see we've got the good old check mark. We can look into it. See our public IP address, service account. As far as connecting, we can connect in with the Cloud Shell. Okay, so that's some other settings that we need to look into, but so we can see that we've created it. We've started out. So Terraform kind of solves that day zero problem of standing up your infrastructure as well as editing it. So let's say, hey, I like the MySQL, but we need to compare to maybe a Postgres database. So there are some similar, you can see if we don't list anything, it defaults to MySQL. But if we go ahead, we add some extra code, add some resources. See, we have a resource that's an instance that it's going to spin up. We're going to add another one. Here's the resource type database. There's database instance. Here's the name. So these all need to be unique as well as the names inside. So this is how Terraform sees it. This is how Google Cloud sees it. So you need to have uniqueness here and here. So we're spinning up two more, or at least one more database instance. We're saying database 2 as the resource name, and then within Google Cloud, here's what it's going to be called. So we're going to need Terraform 2. And you can see here for database version, we're going to go with Postgres 13 and other supported values. This editor is great, but it doesn't word wrap, or it's not as pretty as Visual Studio. I know Visual Studio Code has some nice highlighting and things for Terraform built in. So you can see here we can have a slew of different types of databases. All right, so let's go ahead, we'll save that. Switch back to the terminal. Terraform plan. Okay, database version is not accepted. Let's see what I did there. And a database instance. On the instance up here, so we want to make sure. Going down. There. That should be better. All right. Terraform plan, you can see in addition to what we're looking at, it's going to add two more resources, that database and the instance of database. So it's looking at the state of what was already there and saying, how is the file that you declared different? So we can also run this again and say, why? I spelled that wrong. A little comma in there, or apostrophe. Yes. Go through the process again. All right, this will take a little bit longer. You see it's about 10 minutes. We go back to our SQL menu. You can see we've got another Terraform instance. It's running Postgres 13. Same there. We've got the same stats on virtual CPU, this much memory, storage, not highly available. There's a few options you can pass to change that. And we'll show you one more resource that you can add with Terraform. So if we go here, let's look. There's a few different resources you can create. We're going to look at the SQL user. You can see there's just a couple right there. We're just going to go ahead and rewritten a couple of resources. To show you it's as easy as paste. We could do 1 user, 2 users, 3 users, 100 users, all the same, as long as they were unique. And that's the beauty of Terraform, is it's got what they call idempotence, which means you can have an input and you can always expect the same output. So we can expect, if we have this configured correctly, we will always get the same resource out of it. Got that saved in there. This one should be a little shorter. Another Terraform plan, make sure we got that all right. So right now it's checking the state, saying, here's what's in the file, what you want to have listed. Based off of that, we're only going to add 2 additional resources. It's not going to add everything in the file over again. It's going to add whatever is different from the current state. We're going to add a user and user 2. So I can say, time. Let's check the state. Yes. Perfect. That took about 10 seconds to create users. So we go in now. I believe users are in this menu. Let's see, here's our good user 1, our good user 2. So just as easily as you can create things, you can delete things. Let's go through here. Let's just delete from here up. Go up to here. Delete in the file. Save it. Just do a plan. See based off the state, it's going to compare it. Now we're saying we're going to not add anything else. We're going to remove 4 resources, the 2 users, the 1 database, and 1 instance. So now we can just run apply. So we either do this, or there's a command called Terraform destroy, which would destroy everything in your directory that's defined by the main.tf file. Let's see how long this takes. While we're waiting, let's just look a little bit at the code, a little bit prettier view in Visual Studio Code. You can see I have here Terraform selected, so it's looking at the .tf or the HashiCorp configuration language. That's what it's called, similar to JSON and YAML if they had a baby. We've got different blocks. We've got our Terraform block, see our provider. We've got our provider here, the configuration. This is my project that I've set up. Here is the resource name, the database, name of Terraform. It's going to refer to this, so database resource, and then this specific name, and then it's going to pull this field. So this is populating with Terraform instance. We're going to say the region, here's the tier. Deletion protection is just making sure that you can either not delete it without special permissions, such as with Terraform, you'd have to have special permissions. And then here we've got the additional resources that are the similar setups. We're saying database 2, and within it we've got there, and then our 2 users. So Google SQL user, and then username. Here's the Terraform resource name, and then it's in there. So that's the code. Take a look at this, and we'll cut to when it's done. You can see that took a lot less time. It took about 2 minutes. Now if we go here, it's not our overview, I don't think. So that failed to load, so let's go back to SQL. Now you can see just the one Terraform instance of MySQL. So from here, let's go through just the best practice. With here, in a test environment, we don't want to spend too much money. Let's go with Terraform destroy. It's going to go everything within the directory that I'm in. It's going to destroy all those resources based off the state. We just go through, just review. Here's kind of the Terraform workflow. You write, plan, apply, repeat. So we kind of wrote the code. We were getting it mainly from this documentation, figuring out what we wanted, the naming, all these things. We plan to verify that what we're getting is what we wanted. Make sure based off the state that we don't get 30 extra databases. We just get ones where you need to look at how many files are changing, how many are inserting, and or if any are deleted. Might be cause for concern, and then you apply to make sure it's going to run. So you can do a lot of cool things, making your Terraform dry. You're not repeating yourself. You can modularize it and call different things. If you say, hey, within our company, this is how we set up our databases. We have certain protections. We have certain naming scheme. You can add variables to have a randomized string attached to the end of everything, so it'll scale up and down. So it's essentially like a function. You're just calling it over and over again. You can call a function as many times as you want. It's a similar principle carrying across to more infrastructure. But yeah, there's a lot to do with Terraform. It's just a very basic example of what you can do, and hopefully it'll help. Perfect, so that took about 1 minute, 22 seconds. Let's go back to our SQL just one more time. We'll reload it just to make sure. That's perfect. So we've got no instances here. Killed everything. So those are kind of the basic commands. We've got Terraform plan, or sorry, Terraform init, which is the first time whenever you change providers, that's when you need to run Terraform init. Terraform plan, which is kind of a dry run, checking against your state to see what resource would be added, changed, destroyed. Your Terraform apply is running through those changes. You can run specific flags on your plan. So you can say out flag, and then you can run the apply based off a specific plan file. So you're not getting anything different if you change it after you plan, or you don't look at it when you apply. A few different things you can do. But this is kind of a basic run through of Terraform, what it can do within Cloud SQL.